Hi everyone. So today we have our first seminar session for the transitional-ai group, and Dr. Rohitash will be leading this. He'll be talking about COVID-19 prepared dataset and language modeling for sentiment analysis. I hope, since you're here and you already know Dr. Rohitash, so I don't need to introduce him. Over to you.
Thanks, Arpit, for the introduction. Just want to make a note that this talk was given at the University of Tasmania and University of Melbourne. It's a repeat of this talk. Right, so the overview of the talk, language modeling with deep learning, sentiment analysis for the rise of COVID cases, 19 cases in India. Then we'll talk about topic modeling to compare the major waves in India, and another project about anti-vaxxer sentiments worldwide, and finally about the data release. So what is sentiment analysis? Sentiment analysis is an interesting area, part of natural language processing. Sentiment or emotion, what types of emotion we express in everyday lives, and what types of emotion we express on social media. So analysis basically trying to find how many of sad and happy expressions and related expressions we make. And it's part of text analysis, computational linguistics, and biometrics. So it is used by language models to identify, extract, quantify, and study effective states. Why is it important? It's important to know the psychology behind people, customers, and so on, so that companies can use it for advertising, for example. Or, for example, you can build a better communication with your customers, with your students, with patients, and avoid situations that can happen if you do not understand, and avoid conflicting situations. If we have automated sentiment analysis systems at work, which we do not have at the moment, unfortunately. Sentiment analysis is, yes, as I said, and it is used in customer reviews and surveys as well. And it can be used in understanding political tweets, for example, as well. And I have done some work in that area as well, in comparing the tweets during the US presidential election between for and against Biden and Trump, and the paper is in that area. So what is topic modeling? So sentiment analysis is a distinct area of natural language processing, and topic modeling is another area. So these are two different areas. Sentiment analysis is typically unsupervised learning, right? You could do a bit of unsupervised work in that area, or semi-supervised learning as well. Topic modeling is unsupervised learning typically. Basically, you are trying to classify different types of documents according to different topics or themes based on number of words, type of words expressed. So it is basically used for discovering hidden semantic structures in a text body. And note that a document typically contains multiple topics in different proportions, hence it is a challenge for natural language processing algorithms and models given ambiguity in expressions. And that is also a challenge, not just for topic modeling, but also sentiment analysis, because the way people express themselves on social media, they use a series of jargons, and there's this local expressions, and then sometimes they refer to media, movies, series, characters, use a series of emojis and expressions, right? And of course, abbreviations that kind of change every few years, and we have to sometimes Google these things. The topic modeling is also useful for social media analysis, understanding public behavior in events such as elections. So that could guide politicians to have better strategies on how to convince the public to get votes, which could be good or a bad thing. It has been useful for marketing and advertising. So just a bit of a background in this natural language processing. In our group here, I did not have this area before 2020. So the natural language processing stuff started was the end of 2020. So I joined UNSW with 0 publications of experience in NLP. So I'm a person, a recurrent neural network guy. So my PhD was in this area, mostly training recurrent neural network for neuroevolution, dynamical systems, and so on. So what is a recurrent neural network? Why do we need to know that? Because these recurrent neural networks are the key deep learning methods used in natural language processing frameworks for sentiment analysis and other related tasks, language translation as well. So in natural language processing, language translation, for example, from English to French, Hindi to English, things like that, that's a distinct different area. And recurrent neural networks are quite used there quite often. So we need to look at information from the past. Basically, in a number of problems, we just do not, a number of problems have dynamical nature, and recurrent neural networks have the ability to model temporal sequences and also model dynamical systems. And the language systems, they are dynamical in nature, and they are temporal sequences. So basically, for example, to predict the next word, we need to look at the past and the present expression, so on. So, and when there is a gap between the relevant information and the place that it's needed is small, recurrent neural networks can learn to use past information. So the thing here is that what recurrent neural networks can do, a major property when it was introduced, it can model sequences that are of varying lengths. So if you have like a sequence of size 20 and then another sequence of size 50, you do not need to have a different type of network structure. A simple recurrent neural network can model that. You do not have to change the number of input neurons, basically. The size 20, there will be basically 20 the recurrent neural network will unfold in time 20 times, and for the size 50, the recurrent neural network will fold in time 50 times. So recurrent neural networks typically, those that introduced in the early 90s, they had this problem of vanishing gradient problem, where the length of the sequences or the unfolding of the recurrent neural network, because when a recurrent neural network is unfolded, it becomes difficult for gradient-based methods to train the recurrent neural network when the unfolding is too long. That means the size of the sequence is more than 10 or 15. It was becoming more and more difficult, just 10, length of 10 or 15. So that is a lot of problems have far more. So length sequences. So that is when we have the LSTM network, basically the long short-term memory network addressed. So there's a vanishing gradient problem and also exploding gradient problem. So it was not just a problem of getting information back in time, but it was also the problem of forwarding information forward in time. So from the input to the output layer, if there are too many hidden states, then basically information was not well propagated. If you have more than a couple of hundred sequence length. So that is was a major problem. And so I was lucky to meet Hugh and Shumit Huber in 2011 during the end of my PhD. in San Jose, California, at the International Joint Conference on Neural Networks. And he actually literally explained this, what I'm telling you. And he's the founder, the main guy behind LSTM, one of the key guys. So the interesting guy from Switzerland. So how does that LSTM, how can that be used for language modeling? So you have input characters, and some of the very basic language modeling tasks would be like when you are typing something and there's a next character prediction, right? There's next character prediction, or checking if your the word that you have typed, right, the spelling is correct, and if it is not correct, then automatically correcting the spelling. And you see some of these features in some software systems, such as Grammarly has some of these features. Sometimes the auto correction, you guys remember if it is in Google Docs? Not so, right? Depends, yeah. But at least it highlights that these are the problems and there are suggestions. So these things can all be done with recurrent neural networks. So another basic here is the transformers. What is a transformer? Basically, think of a transformer as an extended LSTM model, basically that adapts the mechanism of attention. So basically, a bunch of guys were having a fight with their girlfriend. They were saying, "You don't give me attention," and they wrote a paper. Attention is all you need. Just kidding, guys. But yes, so that's the paper there. Attention is all you need. And it's like cited, I don't know, 40, 50,000 times by now. There's like a key paper in this area of deep learning. And the idea was to bring this attention mechanism that is coming from cognitive attention that we have today. And they use an autoencoder decoder architecture. So this is a special type of recurrent neural network called encoder decoder recurrent neural networks beyond this talk. And those ideas with LSTM and attention, they are all used together to build a transformer. The problem with the transformer is that it's damn big, you know, the size, it becomes huge because the number of parameters with this attention mechanism, it becomes hard to train. It's quite computationally intensive in training. So in comparison to RNNs, transformers do not require data to be processed in a sequential order, since the attention operation provides context for any position in the input sequence. A major feature of transformers. And it's just an overview of transformers taken from the paper in the literature. And you have input, output, and you can see compared to standard LSTM, there's this multi-headed attention that is added there. And the multi-headed attention, it has a set of operations, scale dot product attention, concatenation, and so on. And the scale dot product attention has its own operations. So zooming in further. So that's there. So what is BERT is basically a pre-trained transformer. Pre-trained models are models where you know that you have a lot of data and you do not want to use your own computer to train. You are basically taking the computational power, making use of the computational power just by downloading the trained sets of weights and biases, right? So that's BERT. That's basically idea of pre-trained model, and it's used. These pre-trained models exist mostly in language models, but there are also pre-trained models in computer vision, areas of computer vision. And the BERT model is developed by Google, and it's a bidirectional encoder representation from transformers. So there's the bidirectional part is there, and it's pre-trained on a large corpus of language tasks. And it has two models. The original one, there's the BERT base and the BERT large. We are in this project, we are using the BERT base with 12 encoders and 12 bidirectional self-attention heads. And they are pre-trained from unlabeled data extracted from a corpus with 800 million words, in English Wikipedia with 2,500 million words respectively. So you can see that it's a huge data set. And if you want to train it from scratch, then that's going to take a lot of computational power. That's why it's there. It's the basic one is they are free to download and use, but then the large ones and there are other advanced versions will pay to download. So in the area of language modeling, you may be thinking so far that, hey, we have been using deep learning and we are looking at text data. What happens when you have, we have been looking at numeric data, but what happens when you have text data? So note that at the end of the day, all the things that you see here on the screen, they are, if you look at the S key, these are the numbers, right? Everything can be translated into a number. So in the early days, if you see their papers as early as 2012, 2013 papers, they were like, if there's a natural language processing task, then there were people were having a very large LSTM, they would have 10,000. So if it is a sentiment classification task, then they would be like, okay, the 10,000 words in the English language are the most used. So what do? We would have a one-hot encoded vector of size 10,000. And for each word, basically, there's one file, right? One of those values. And you will have the LSTM network with, if there's a sentence with, 10 words, then you'll have 10,000 by 10. So 10,000 would be the size of the inputs in the LSTM. And that was not a very smart way to do things, but people were doing it. So that's basically the easiest way to use natural language processing with deep learning. You just use one hot encoded vector as an input. But then word-to-vec and global vectors, these are smart ways to basically encode, have some type of a model that takes the text data and that creates a latent vector representation. And basically you use that latent vector as an input to your LSTM or your transformer or whatever the deep learning model is. So here, these are also known as context-free models. Word-to-vec is actually a neural network-based model. And they generate single word embedding representation for each word, right? So these are basically you have like a size, each word instead of 10,000, you will have just a vector of size 500. And because these models are trained, they have in natural language processing, there are some words that are expressed more than the others. There are some rules that how the word should occur. So those things are captured better with word-to-vec and globe. So that small vector representation basically ensures that you're using less memory as well and better capturing the contextual information, the context of the word. So BERT takes into account the context for each occurrence of a word, even word, which makes BERT one of the best language models. You can use BERT as well for that. So you have semi-supervised training on large amounts of text, books, Wikipedia and stuff. That's what BERT is doing. And then you supervise training on a specific task with a level data set. So you have this semi-supervised training, and you have a pre-trained network, and you are taking that pre-trained network and you have some data set. So rather than training your network from scratch, you're training using the information from the pre-trained network, and then you are fine-tuning with the training data set in your case, which probably is not been used in the data of the pre-training network, right? So we are going to go into further examples. So here's like an example of email message data set, which is a spam and not spam. So how BERT comes into place is you could do this supervised learning without BERT. For example, you can use a basic neural network based or machine learning model. But the BERT basically, because it's pre-training with the large corpus, it gives more contextual information of information present in the data. So it's supposed to help you get a better decision. Right, so that's all about BERT. So in this project, the focus was, that's the background, the focus was social media and language modeling. And we know that the advanced deep learning modeling models, they have been promising for sentiment analysis, and they have been used a lot with social media networks such as Twitter. The reason it's used a lot with Twitter is because Twitter has this interface to download tweet data, whereas it's harder to do in other social networks. The other thing is the feature of Twitter is, if you compare Twitter with Facebook, in Facebook you have a lot of people just sharing their messages, posts as within their family and friends. So that's not public information. In Facebook, only the Facebook pages are public. So anything that's given in the Facebook page, that's published as general public. And there are papers where people have used those information to mine certain things during COVID and related, trying to track related problems. But Twitter has been used more extensively. And hopefully with Elon Musk buying and changing the structure of Twitter, there's going to be, hopefully it will be more helpful for researchers. It's kind of, even to download the data, we'll come to that towards the end of the talk. It's quite a challenging task for Twitter. So as noted earlier, it's been used for political campaigns, protests. Sometimes it's peaceful, sometimes they have led to riots, and hence there have been a number of cases where different countries, cities, they have blocked Twitter for a certain time as well to take care of these issues. And as I said, that I have another paper which is looking at Biden versus Trump during the 2020 presidential elections. And there's a huge good trend there that you see in the paper in forms of maps about the different sentiments to and fro each of the candidate and how they relate to them winning the different states. Yeah, can give a talk about that in the future. So why COVID-19? And we are all locked up, and there was nothing better to do, I would say, as well. So and there was this some interns from India, they wanted to do work with me, and I was like, okay, let's do something where we do not have to run for the data, and we need to ensure that all the things we do is open source. So, and we can share the code, so we do not have issues. So that's why we focused on COVID-19, and this visualization of the virus is well known. So why sentiment analysis? The thing that motivated me the most was personally is that so far in human history, at least known human history, we did not have this much of information documented, especially during a pandemic. Never, right? And I think that the amount of information when we're looking at sentiments, we can and other the text information, it would probably can help psychologists and neuroscientists understand how people react during such pandemic situations. And there's a number of papers which are looking at already topics expressed in Twitter and other social networks that relate to depression, or even go as far as trying to determine if somebody is about to commit suicide. So this is about enabling. I was motivated about doing something that would enable a better platform in the future, at least setting the foundations for it. So, and during the COVID-19, as the cases were rising, there have been stricter lockdowns. People were really upset, and this is all well known. And deep understanding of human psychology during catastrophic events is important. And we basically present a framework where we are trying to use LSTM networks part, and we just focus on the COVID-19 cases in India. Why India is a major thing was that there's less work done for India. Right? India had a very unique trend in the COVID-19. There were like three sharp, if you look at Indian cases, there are three major peaks, right, or waves. And I thought that it is easier for us to focus on them and compare them. So we use a series of other things. We also use global vector encoding language model, BERT language model. And so we cover the first major peak of novel cases. And we are focusing on multi-level sentiment classification. Multi-level classification is when you have one level, more than one cases. For example, in a level, a tweet can be sad and optimistic at the same time. Sad, optimistic, and joking at the same time, something like that. And we know that if the statements we make in the public, when we go to a bar, when we're talking with our friends, there's so many different sentiments that we express in every statement we make, and it's usually not just one, right? Sometimes we express things that the sentiments that it's hard for us to know ourselves what we have expressed. So this is a big challenge for machine learning, right? To find what types of sentiments have been expressed. Sorry, I just right, and what time? Right, so the major framework, which I always stress in all the papers, that we need one figure that basically captures the whole paper. And actually these days in Elsevier journals, they will ask you for this type of figure as well. They'll say, what is your, you need to upload one figure, which is like a graphical abstract, let's say. So we have all these social networks, communication channels. The tweet pre-processing, this is looks simple, but this is one of the most tricky issues, it takes a while to do that. And then once you're done with that, then model development is easier. So in terms of training, we have these human level sentiments. It's a COVID-19 dataset called the SendWave dataset. In the SendWave dataset, there were 10 sentiments plus one level called official, labeled by human experts for 50,000, no, 10,000 tweets. How do I? Okay, sorry. Right. So for 10,000 tweets. So as I showed the figure earlier, there's this, we are using the BERT language model, and we are not just using the BERT, we want to compare BERT with just the LSTM model alone as well, so that we have some interesting results to discuss. And the BERT model does not have the data set that we are using for training, because it's a pre-trained model, and that pre-trained model did not have that data set. So basically, that's where we are fine-tuning that pre-trained model with the SendWave data set, 10,000 tweets. And this is a really good data set in my view, and we are working on a number of papers with this data set, because if you look at the sentiment data sets out there are not that many data sets which basically are multi-level classifications, and they are not the main one is the IMDb sentiment data set, which basically gives you polarity score -1 to +1. And with that, you do not really get that much information of what types of sentiments were expressed. You just know what was the negative and the positive type of sentiment. So you can't do really that much of analysis with that. So that's why we found this to be interesting, and we use that. So here, what we have here is basically just some data analysis of the test data set of the first wave of COVID. What you can see here is in red, you have the number of cases, and you have the tweets in red. Sorry, in red you have the number of tweets expressed, right? So this is when India March, the cases started a bit late, and you see the blue, the cases, they exponentially increased, but the tweets, I mean, in May it almost doubled, but then it remained there like a bit high. And after this September, then this kind of goes lower. So that's the peak is reached around end of August, September. And then it seems that people are like, they don't care that much, right? So which is neat. So what types of sentiments were expressed? Coronavirus, COVID-19, fold and hand, or namaste, sorry, please, positive case, social distancing. See that first two, that's natural to understand. This is people who were requesting a lot of things. So, and the third one, positive case. I mean, just if you think back again on all the things that were in social media, in the media, these words do relate, and then this index pointing, this is and smiling face. So we also, if I steer, we have all these emojis that were basically translated into words, and there are a lot of emojis were expressed, and also the folded hand is an emoji. So you see that a combination of things. And similarly, the trigrams, the light skin tone, I don't know what it means, but it seems to be expressed. It seemed maybe it was an emoji, smiling face, smiling, is all emojis, face smiling, and get well soon, not emoji, I guess. Dear Joy, this is also emoji. The first one also. So lots of emojis expressed. And the SendWave data set, we analyzed the training data set, trying to understand how things are there. You see that we have optimistic, and this is human leveled. This is human leveled. Experts have leveled this data set, and if, for example, this is just, we are just looking at the tweets that have two sentiments expressed at once, right? So you have optimistic, and then okay, you have optimistic and joking. So joking is expressed quite heavily with optimistic in this. Then you have thankful, optimistic and surprised and thankful. Then you also have optimistic and pessimistic. That is like a difficult one to decipher because, and then for the joking, you have optimistic, thankful. People are usually annoyed and joking as well. Some of the official reports were seen as joking. Officials were making a joke. This is what the human experts found. That there's some, by the way, I mean, for this, I think joking is not the right word. Let's say humor, okay? There's some sort of humor expressed, basically. And sometimes in official reports, this is like very difficult times, right? So people are writing in a way to get attention and express some form of humor. So, right, so that's, and now we are basically the trained model. We are, and this is the BERT one. We basically found that the BERT model is expressing we had a small test data set. In the training data set, we found that the BERT model was better in training. So we are presenting the results for the test data set only with BERT. So, and of course, it has this whole corpus of Wikipedia and so on in the BERT-based model. So here we find that optimistic, we have joking and thankful. So in the data, the training data set was 10,000 tweets stretched throughout the world, whereas here is just focusing on India. This is the training data set throughout the world. People were, if you see the previous one, here you have, they saw optimistic and humor more, and they found less thankful. But in the case of India, people were optimistic and more thankful compared to the average of the rest of the world, you know, when the world combined. So that's it. They had a different approach to the way the pandemic was handled. It was not honky-dory. Things were quite difficult in India, just as the rest of the world, but we can see that the conclusions are a little bit different when you look at the data. So, and then we have surprise, annoyed, surprise. Let's say the second category, then the third is anxious and empathetic. And then we have optimistic and pessimistic very less, and sad very less, because in denial, because, you know, then it's hard to be writing a sentence that is optimistic and sad at the same time, right? So this is what found. And then in the joking, similar things are expressed here. Joking and annoyed, quite heavily expressed, and joking and optimistic. And some of people were joking and also being sad, or presenting some form of humor and being sad. So the number of levels, that means how many of the tweets had more than 3 levels. There's none of them, because it's very hard to express 4 emotions in one expression, I guess. But most of them is either 1 or 2, you know. And sometimes you can make a neutral tweet. So this is over time. What we find is as the peak was growing, we have people were quite optimistic in India, July and August and September. Throughout, people were generally optimistic. This is just one for the one level expressed, you know. So they were mostly optimistic. And then they were thankful. But then they have been joking quite a lot as well. See, the color of joking and optimistic are very close. So joking is the second. In this case, this is the joking. And they were sad as well, quite sad. And so you have optimistic, sad, and joking as the three things expressed throughout the. And afterwards, then they were quite optimistic in July, and you see, now September, the peak was reached. So they didn't need any more optimism, I guess. The optimism and the sad tweets are very close here. Joking is quite close as well. So those were some of the main things that were expressed, which I am summarizing here as well. Just moving on, run out of time. And the other project is trying to use these sentiments to look at anti-vaxxer sentiments. An example is retire the use of the term anti-vaxxer. It is derogatory and marginalizes both women and their experiences. Crazy mothers. Why? I don't know why those two words are they're placed together. Then you have okay anti-vaxxer. Right. So you have all these sorts of Twitter words. Just got it from board Chandra. And that says a lot about how the situation was back then. So this is another project, it's an ongoing project, and it's supposed to submit this paper for review 6 months ago, but then this perfectionism bug got to me. I'm like, okay, let's try to improve it further and further, and then did more and more work, and then people got tired and left. So we still have the paper, and hopefully we'll submit it in January. And the idea is to get the sentiments that is related to vaccines, basically during the pandemic, and then look at the different types of sentiments expressed. And from those sentiments, try to have some type of a rule-based system, or see what combination, make some assumptions of some combinations of sentence, so as to see which tweets are pro-vaccine and anti-vaccine tweets, and use the same data set basically. So that's the major framework. And instead, basically, it's a similar thing, but the data is, there's a post analysis, which basically determines anti-vaxxer tweets. And the data here, in the previous one, it's all the data, whereas here is the data that only expresses something to do with vaccines. So, and this is vaccine tweets in that range. And some analysis of the data, sentiment level, mostly no sentiment level, so on. And this is some preliminary results for the entire data throughout the world. What are we doing now is doing some post analysis on this to see how many are pro-vaccine or anti-vaccine tweets. In here too, we find that optimistic in this, when it came to the data about vaccines, a lot of tweets expressed were optimistic, and I think the others there are some joking tweets as well, and annoyed as well. So, and official. It's a lot of official tweets, the blue ones. So because there were official tweets were released quite frequently. So according to a model, so we have some scores. So this score is the sentiment polarity score. So we are doing not just the multi-level sentiment classification, but we also using the IMDb dataset to show a polarity score, and we're going to combine them try to understand if that's a pro-vaccine or anti-vaccine. So sad and anxious, please move, we need a vaccine for corona, we need to complete our normal lives. So, and deny never, what they can do, we are just used to no idea of the impact. Unfortunately, a lot of people became experts during COVID and tried to express something as an expert or posing as an expert. So what we are doing is, that was for the world, and then we are now looking at different countries, some major countries that have Twitter population, and vaccine related tweets in till December 2021, and total and vaccine related in these things I just said, that we find that more tweets were optimistic, and it sends an important message to public health professionals and disease control bodies that they should increase the transparency and timeliness of information released to effectively keep the public informed to minimize spread of misinformation about vaccines, and also an effort to restore faith in the scientific evidence and to reduce ungrounded anti-vaccine sentiments on social media. Hopefully, this is a very solid statement that can hopefully that can happen. So then moving back to India, because we had 3 major COVID-19 waves. So I was like, in those 3 different waves, there were different things happening in India and also the rest of the world. But in India, you had like the first wave, there was a lot of tweets about lockdowns. The second wave, there was this Delta variant, and there was not much lockdown, but the national lockdown in the second wave became state level lockdowns, and the states began fighting, and there were pro central government and against central government states that did what the central government wanted, the ones that were against. And then because of that, some states had more COVID-19 cases than the other. Like for example, Maharashtra and Delhi, they were the worst affected in the Delta variant. And they are not the pro-government states, but the other states such as Uttar Pradesh, which is almost double the population of Maharashtra, maintained Delta variant quite well. If you look at the stats. So the first wave, the tweets, some data, and the cases. This is basically the peak cases that were reached in the first wave, and then the second and the third. And basically, this is topic modeling. It's a different ball game, and we have this IEEE data port from where you get the data, second, third waves, and then tweet hydration. We extract the data ourselves. See, the work done previously, we were relying on data from other people who extracted. But the thing is, those people, they only covered the data in the first wave. So second and third wave, I had to set server at my home, and there were 2 interns. Janvi was mostly part of this project from the beginning. And then Kathy, who is a master's student here, she started it and Janvi took over. And Janvi was checking this every day for, about 8 months to download the tweets, because the Twitter hydrator application, it stops every day or every 2 days on its own, and then you have to restart it manually. So it's a very painful task. And now we have that, and the data sets. I'll come back to that later. So we have this different, so this GSDMM, this is more, but these 2 are canonical methods for language modeling, the LDA, and we are comparing it with BERT. We note that the BERT is used in the topic to web pipeline to create document embeddings, and then we are basically, we have like a series of latent vector data, and that is unlabeled, and basically we are taking PCA and UMAP to compress it or get the features out of there. And then we apply, so PCA, we get the principal components, let's say, that the top ones. And then we apply these k-means and HD-based scam and others. And then we do hierarchical topic reduction. So this whole thing is a lot of things are used in this framework. Whereas in here, in LDA, all those things are, different approaches are used and done. So, and there's the topic coherence, score comparison, and so on. So we want to see the three different waves and how they compare with each other. So in order to see how well the topics are extracted, we need a measure, and that measure is NPMI. And that's a way to get topic coherence. But the thing is, this measure is, how good this measure is still debatable, because a lot of this measure has been applied to more of non-short text, Twitter-based text, but no normal text like newspapers or books. And it's still questionable how well it is doing. But for the first wave, we have the data. And this paper is, we will release this paper in January in archive. We are towards the final stage of this paper. And here, basically, with the topic coherence measure, we find that the BERT-based topic model is doing much better. It's getting similar types of topics, but it's a much better model. And this BERT-based topic model is very new compared to the rest. It's just 2 years old. And we are doing, so there's another paper where I'm using the same thing for Hindu philosophy, where we are comparing topics of the Upanishads versus the Bhagavad Gita. These are two separate Hindu books, which have some common features as well, and they influence each other. And there we also compare a number of different clustering algorithms and so on in the framework, and we report those details there. So that's a good paper to look at in evaluation of what methods to be used. So there's different topics and how these topics basically overlap with each other. With UMAP, you can think of it as a PCA type of method, where you are just taking the first two dimensions to show the visualization. And the interesting part here is that, so you have, let's say you have the two waves, the two topics, and then we want to know how much of the topics across the first and the second wave are, or what's the correlation of some of them. So this is basically the approach that we are taking, to use this type of a matrix and comparing the different topics. And for example, here topic 1 is highly correlated from the second wave, is highly correlated to topic 2 from the first wave. So it could be that the topics may be about lockdowns. One would be about national level lockdown, one would be about state level lockdown, and people are tweeting stuff like that. So we yet have to properly present these results in the paper, and still this is preliminary results, how the topics are formed and how they are, what are some of the keywords in the topics. I don't know, topic 3 is Amitabh Bachchan in there as well. Probably I think he had COVID, right? And he was in Twitter, he came in Twitter during that. Bharat Kejriwal, who's Chief Minister of Delhi, Hindus, Hindi, and Modi government. So these are all different topics. As you can see, this topic is mostly about lockdowns here, whereas these other topics are some things about political issues as well. And then we have Chinese virus, China virus, which was trending for some time as well in the beginning, right? So it trended for a while, so it was a topic of its own. And the second wave topics we do not see. So these things are more in the first wave topics, but second wave topics changed quite drastically. We do not have this whole China virus things in the second wave. People started to understand that it's not to do with a country, but it's a general problem for the whole world. So then further UMAP embeddings for the second wave. And in the paper, we do also second wave versus third and first versus the third wave to see the topics and how the topics basically overlap with each other. And the heat map basically shows high correlation of certain topics, and we are going to show more details in the paper. And we'll do further analysis of the topics during the respective waves by comparison with the COVID-19 novel case trend with media sources in the newspaper and so on. What types of topics were expressed in the media, and we're doing that in the paper. So finally, the release of the global COVID-19 Twitter dataset. It was very difficult during COVID-19, and it's good to have a data set. So we provide easy access to tweets from COVID-19 for some major Twitter active countries, UK, Brazil, USA, India, Japan, and so on. And thanks to the people involved here, these are the number of tweets. As you can see, the most active country in Twitter is United States, and this is like almost 20 GB data set, and around 10 GB is just United States. And we also have a lot of vaccine-related tweets there. As India, although it's a large country, there's not that many Twitter users. Then we have second largest is the UK. So the global tweets and tweets counts for different countries. These are all released with the data set, and the data set is released in Kaggle. So the data set is from the tweet IDs by Rabindra Ramsal, and he is a second to third year PhD student at University of Melbourne. So in my trip, I met him. And he maintains, so in our Twitter data set that we are releasing, it's 3 days a week, whereas Rabindra has for the entire week. So there are a number of issues in the release of this data set, and there's to and fro. Rabindra says that he's been told by Twitter and some other sources that he cannot release the data because he has the whole global data and he has terabytes of data. And because there's a Twitter policy about release of the data. But what we have done is basically remove, with Twitter policy is that you cannot have the tweet handle and the tweet IDs and the tweet when you release the data. So all we are doing is taking the tweet handle out. So you do not know who the data is, the tweet is from, and we have yet to re-release the tweet handles and give it some ID so that you can do further analysis. It's like from a research perspective, maybe it would be important to know that that tweet is from that same person of a series, and you can see the trend, what that person has been doing on Twitter, and to understand the psychology behind the person across the tweets or a group of people. So that many tweets per day, and due to this hydration of tweets, is selected only 3 days, 2 GB per day, and the JSON format for that is 20 GB, and yeah, that's the size and so on. And this is the link to the data set, and we can do a lot with this data set in this group. Many thanks to Jahnavi. She's actively fighting to complete this project. At the moment, she's doing some exams and placement exams. Yashwan came in for a while. Kathy started the project. Arti from Fiji, good friend of mine, she's part of the project. And Ashwin, he's published here the first paper in the sentiment. So I think he's working probably. Right, so many thanks to everybody. And the papers and software. So yeah. All right. Thank you, everyone. Any questions or comments? Maybe you can switch on the microphone.
That's all.
Okay. Yeah.
You mentioned that the pre-processing stage for the tweets is very difficult. Do you do anything to like filter out bots that are making these tweets? Or is that part of what you're doing?
Yeah, I think Ashwin did the pre-processing those bot tweets out. But the thing is, like, it's those that are obvious, he could take it out with some rules, right? But sometimes it's not so obvious if it's a bot or not a bot. So
And the Twitter API doesn't provide any.
no. So, but the thing is, and also it's like we can use that if we can really detect that well, then we can write a paper to report that. So that the other thing that I was discussing with Ravindra from University of Melbourne is that a lot of people, they delete their tweets, you know. So he has the data, like terabytes of data. And now if you download the data, then it's not there. So that's another thing. So people don't necessarily delete, they would be deleting their account and creating new accounts. But then Twitter will not, you can't download the deleted account information, right? And that's important thing for research actually. So he has that. And for all of these papers, they have the software code along with them. Can I show this probably here? Just a second. Yeah, so you can see here that for the COVID-19, a lot of people are some of these projects, people are cloning the repositories and trying to reuse them. So that's a good thing. So it's not just impact in terms of citations, but people are trying to clone the repositories. So any other questions? Yeah, we can take one more question. No? No? Okay, thank you everyone for listening. Let's end here and move to the bar. How do we do it?